Welcome friends, I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you found the right place. Before we begin, I'd love to know where in the world are you listening from. Perhaps you're wrapped in a blanket, sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable and ready to wander with me into the quiet story of a world that never formed a planet whose absence reveals more about the solar system than its presence ever could. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. The narration flows without pause into the early solar system, drifting backward through time until the sun is young and the planets have not yet taken their familiar shapes. The star glows with a light slightly dimmer than today's, wrapped in a disk of dust and gas that extends in wide spirals around it. Within this disk, trillions of grains move in near silence, each one warmed by starlight and pushed ever so gently by the solar wind. The scientifically accepted fact grounding this moment is simple, but immense planets form from these grains accumulating through collisions, adhesion, and gravitational gathering until some become worlds, while countless others do not. Only took the faint tapping of dust upon dust to begin the building of everything solid. The narrator lingers on the disk's texture. Its bands form subtle patterns sculpted by inflowing gas spiral density waves and turbulence. The dust is not uniform. Some grains carry water ice, others carry iron, others silicates. A poetic detail emerges in the way these grains shine under the young sun, their reflections forming soft halos along the densest bands, as if the disk carries its own faint luminous breath. Only took scattered flecks of rock to paint the solar system's first quiet rings of light. Yet even here in the earlier stage, a scientific uncertainty rests gently. How turbulence shapes the disk remains partly unknown. The precise balance of magnetic forces, pressure gradients and gas dynamics continues to challenge models. Some regions clump dust easily, others resist accumulation. Only took a shift in invisible currents to change where future worlds could appear. Small clusters begin forming first pebbles, then boulders, then kilometre-scale planetesimals. They drift within the disk like slow-moving embers in a vast cool fire. Collisions shape them. Some merge and grow, others collide too fast and shatter. The physics is patient but unyielding. Only took a slightly higher impact speed to turn construction into destruction. The narrator drifts through this region with unbroken calm, following the slow dance of bodies that will become the solid architecture of the solar system. Some grow steadily, forming planetary embryos tens to hundreds of kilometers in diameter. These embryos scattered across the disk begin clearing paths around themselves, carving subtle grooves in the gas and dust. Only took the soft pull of gravity from a small growing worldlet to shape a corridor through a million drifting grains. But many others fail to grow. The disk's density varies. Its inner regions teem with material, while regions farther out experience slower growth. Motion is constant but gentle, shaped by gas drag, radiation pressure, and gravitational interactions with nearby bodies. Some embryos migrate inward, others drift outward. Some spiral slowly into the sun. Only took the faint friction of gas to set a future world on a path it could not escape. A quiet scientific mystery lingers why some disks produce many planets, and others produce few remains uncertain. Observations of exoplanetary systems reveal extraordinary diversity. Tightly packed systems, widely spaced giants, missing worlds, super-Earths, hot Jupiters, each shaped by conditions that models cannot fully capture. Only took a subtle variation in disk chemistry or temperature to send two systems along drastically different evolutionary paths. The narrator continues drifting outward, watching the early solar system form structures that hint at the worlds yet to come. The innermost region glows with heat too warm for water ice. Silicate-rich bodies gather slowly, forming the seeds of Mercury, Venus, Earth, and Mars, though even now they are mere shells of their future selves. Beyond this region, water ice becomes stable, allowing planetesimals to grow more rapidly. Farther still, the giants begin forming Jupiter first, then Saturn, their immense masses shaping everything around them. Only took the gravity of one growing giant to alter the fates of countless smaller worlds. In this serene early epoch, the seeds of a missing planet also appear not a fictional world, but a scientifically grounded possibility that emerges from the physics of planetary formation. Between Mars and Jupiter, material drifts in abundance but cannot assemble into a stable world. Turbulence resonances and the looming presence of Jupiter keep this region fractured. The narrator lingers in this corridor, sensing the quiet irony that the solar system holds room for a planet here, yet will never allow one to form. Only took the pull of a giant 5 times farther away to prevent a world from being born. Dust continues to circulate. Embryos continue to collide and disperse. Some grow for millions of years before being destabilized by gravitational encounters. Others survive longer, but never become large enough to clear their orbits. The story unfolds not through dramatic collisions, but through the slow, cumulative effects of countless small interactions. Only took tiny nudges repeated endlessly to erase the potential of one more planet. The narrator moves gently into the outer regions of the disk where the young sun's light dims, and the material becomes colder, darker, and thinner. Here, the future Kuiper Belt whispers its distant presence, a region where icy worlds accumulate without ever merging into a single body. Patterns repeat: growth begins, growth stalls, growth ends. Only took distance from the sun to slow the rhythm of growth to almost stillness. The early solar system rests in this quiet state dynamic, yet calm, chaotic, yet smooth. Planets that will endure begin taking shape. Planets that could have been fall away from possibility. The missing world, the one shaped by absence rather than presence, remains unformed in the space between Mars and Jupiter. But its story is just beginning. The narrator senses its outline not as a real planet, but as a pathway shaped by physical laws, a world implied by what could not happen. Only took the silence of an unfulfilled orbit to shape a mystery woven through time. The narration moves without pause deeper into the protoplanetary disk, drifting along the bands of dust and gas that swirl around the young sun in patient spiraling arcs. Here, the guiding sensation becomes the long, unhurried process by which simple grains evolve into the beginnings of worlds shaped by sunlight temperature collisions and time. The scientifically accepted fact grounding this moment rests in the fundamental mechanism of planet formation. Dust grains coalesce through processes like van der Waals, forces electrostatic attraction, and finally gravitational gathering as bodies grow large enough to influence one another. Only took a quiet stickiness between microscopic particles to begin the architecture of planets. The narrator glides through regions where dust drifts in soft, slow-moving currents. Tiny grains collide, gently sticking together for reasons almost humble: molecular attraction, surface texture, chemical compatibility. These grains clump into larger aggregates, forming pebbles up to centimeters across. A poetic detail emerges in the way sunlight scatters through these particles, casting faint golden beams through the denser regions like soft rays filtering through calm water. Only took scattered flecks of light to reveal how dust begins organizing itself into structure. Yet a scientific uncertainty lingers quietly. How pieces larger than a few centimeters avoid fragmenting remains unresolved. Collisions at this size often bounce fragments apart. Some theories invoke streaming instability. Others highlight turbulent eddies that concentrate solids enough for gravity to act. Only took a faint increase in local density to turn drifting pebbles into the seeds of planetesimals. As pebbles gather, they grow too heavy for gas drag to carry freely. They settle toward the midplane of the disk, a thin, dense layer, where the concentration of solid material increases dramatically. The narrator drifts along this mid-plane, sensing how subtle shifts in gas pressure create traps, where pebbles accumulate more easily. Only took a small ridge in gas density to build a cradle for the next stage of planetary growth. Bodies several meters across struggle against drag forces, often migrating inward toward the sun. Some spiral slowly and disappear into the star, others bypass destructive paths through regions of relative stability. The physics here is delicate and continuous, shaped by interactions that play out over thousands or millions of orbits. Only took the subtle difference between drift speed and turbulence to determine whether a future mountain or moonlet would survive. The narrator lingers in zones where turbulence forms swirling eddies, gathering pebbles into dense clusters. These patches grow heavy and gravity begins to matter. Pebbles collapse inward, forming kilometre-scale planetesimals in short bursts of accumulation. This rapid gravitational collapse is one scientifically accepted solution to the meter-sized barrier, allowing growth to jump forward from small clumps to substantial bodies. Only took a brief moment of local concentration to skip an entire stage of slow, grinding growth. A poetic detail emerges in the forms of these planetesimals, which remain irregular, rough and scarred. Some rotate softly, others tumble slowly through the disk. Their surfaces are mottled mixtures of rock, metal, ice and ancient dust, the earliest textures of the solar system. Only took the absence of atmospheric smoothing to keep these bodies true to their origins. Yet another scientific uncertainty rests here: the precise distribution of temperatures within the disk, where water ice forms, where carbon compounds condense, still challenges researchers. Each region hosts different materials influencing what future planets might contain. Only took a narrow change in temperature to decide whether a planet begins rich in rock or ice. The narrator drifts outward slightly toward regions cooler and denser in volatile materials. Here, icy grains stick more readily than their rocky counterparts, forming larger pebbles earlier in the process. These icy pebbles accelerate growth, helping form the cores of gas giants. Only took the presence of frozen water to speed the building of worlds larger than Earth. Yet growth does not proceed uniformly. Bodies collide, some merge, others fragment. The disk shifts, continuously sending planetesimals into new orbits where they meet new neighbours. Some become planetary embryos, lunar-sized masses capable of shaping their surroundings. Only took repeated low-velocity collisions to turn drifting rubble into a worldlet, with gravity strong enough to collect more. The narrator drifts through a region where dozens of these embryos coexist, each clearing small paths through the disk, each exerting subtle gravitational influence on its neighbours. Their orbits are not stable, but shifting, weaving among one another in slow-motion gravitational choreography. Only took the slight pull of a nearby embryo to change an orbit that seemed settled. Beyond them, dust continues to rain inward toward the mid-plane, feeding the growing bodies. The disk stretches far from the sun, its outer regions colder, darker, and richer in volatiles. The narrator senses a pattern where dust is rich. Growth accelerates. Where it is thin, growth slows or fails entirely. Only took a minor reduction in dust density to halt the making of a future world. A poetic detail emerges in the dust diversity. Some grains contain pre-solar materials, microscopic fragments, older than the solar system itself, forged in ancient stars. These grains drift through the disk as quiet relics of cosmic history, becoming part of planetesimals and eventually planets. Only took the remnants of long-dead stars to seed new worlds with their chemistry. Yet amid these processes, the narrator senses the first hints of the missing world, the region that should form a planet but will not. Between Mars and Jupiter, dust gathers, collisions occur, embryos grow. But the environment feels different. Slight gravitational perturbations from Jupiter ripple through the region, stirring orbits into instability. Only took the distant presence of a giant planet to alter the fate of millions of tons of drifting rock. Planetesimals here collide more frequently, but the collisions are energetic, leading to fragmentation instead of growth. Embryos attempt to form but lose mass rapidly. the region becomes a cycle of creation and destruction, never reaching the stability needed to assemble a planet. Only took an orbit slightly out of resonance to turn constructive impacts into shattering blows. The narrator hovers in this region with calm focus, watching the birth of material that will never become a single world. The dust continues to produce pebbles and rubble, but the path toward planetary identity remains blocked. This silence, the silence of the planet that almost could have been, lingers like a faint gravitational shadow. It is here that the concept of Nibiru takes its first scientifically grounded form, not as a hidden planet or mythical intruder, but as a reflection of what early solar system dynamics prevented from ever existing. Only took natural gravitational constraints to craft a planet defined entirely by its absence. The narrator moves outward again, passing from the mid-plane into thinner gas where sunlight filters weakly. In these regions, dust clumps more slowly, leaving long trails of grit and ice that will eventually drift into the outer belts. The early solar system now holds the seeds of all future worlds, Jupiter growing swiftly, Earth slowly assembling distant icy objects forming quietly at the disk's edge. And between Mars and Jupiter, the silent signature of a world undone by gravity remains untouched, a corridor shaped by the combination of dust distance and the influence of giants. Only took the interplay of forces older than planets to carve a space where a world should have formed but did not. The narration drifts seamlessly into the deeper turbulence of the young solar system, moving across the shifting boundaries where small worlds rise and fall under the influence of gravitational encounters. Here the guiding sensation becomes the quiet but inevitable instability that shapes early planetary orbits, a slow, continuous rearrangement of trajectories influenced by every neighbouring body. The scientifically accepted fact grounding this section is that during the solar system's first tens of millions of years, planetary embryos frequently scattered one another through three-body interactions, altering eccentricities, inclinations, and orbital distances in ways far more dynamic than the stable patterns we see today. Only took a slight gravitational nudge between two drifting bodies to rewrite the fate of an entire orbit. The narrator glides alongside these migrating worlds, sensing how their paths overlap like faint interwoven threads. Unlike the calm ellipses familiar in the modern solar system, young orbits wobble, stretch and contract in response to the shifting mass distribution within the protoplanetary disk. Some embryos experience repeated close encounters, their paths altered each time by the pull of passing neighbours. A poetic detail slips softly into view. Dust stirred by these interactions forms faint spirals trailing behind each body like tranquil wakes behind boats drifting across a still water surface. Only took the passage of a single embryo to leave a flowing trace in a sea of dust. Yet a scientific uncertainty lingers here. Although simulations reconstruct many aspects of early orbital chaos, the exact number, mass and distribution of embryos remain unknown. Some models suggest dozens in the terrestrial zone, others propose hundreds. Only took one parameter slightly altered in a simulation to produce an entirely different planetary arrangement. As the narrator follows these paths, gravitational scattering appears not dramatic but gradual, a cumulative process unfolding on timescales that feel long, even in an environment shaped by youth. Embryos pull one another into more eccentric or inclined orbits. A few drift inward where gas drag accelerates their migration toward the sun. Others drift outward, approaching the domain of the giants. Only took a small increase in orbital eccentricity to push a body into a region where long-term survival becomes unlikely. The narrator drifts into a region where two planetary embryos approach in slow gravitational embrace. Their encounter does not lead to collision, merely to a quiet exchange of momentum. One is nudged inward, the other outward. Over millions of years, these small adjustments accumulate, reshaping the architecture of the terrestrial planets. Only took a single near miss to set two future worlds on diverging paths that would never cross again. Beyond them, Jupiter's influence continues its steady reach. the giant's gravity resonates across vast distances, sculpting the disk not through forceful impacts, but through subtle, repeated tugs. Mean motion resonances send gentle pulses through the region between Mars and Jupiter, disturbing the orbits of smaller bodies with rhythmic precision. Only took the quiet heartbeat of a distant giant to disrupt any attempt at long-term stability nearby. A poetic detail emerges in the resonance zones themselves, which appear like invisible corridors spaced throughout the disk. Though the dust and gas show no visual markers, the gravitational landscape forms predictable gaps and bands shaping where planetesimals accumulate and where they disperse. Only took the mathematics of orbital timing to carve patterns into a region where no solid boundary exists. The narrator drifts along one such corridor where small bodies accumulate only to be dispersed again. Embryos here struggle to maintain their orbits as Jupiter perturbs them repeatedly. A few moments of equilibrium arise, but they never last. The region is defined by impermanence, the gravitational equivalent of shifting sands. Only took a slight deviation in orbital period to end the stability of a body drifting in the wrong place. The young Earthling bodies, the early embryos that will form Earth, Venus and Mars, appear in contrast as somewhat more sheltered, though still influenced by interactions with each other. Collisions among them remain common. Some merge, forming larger embryos that seed future planets. Others shatter, creating fields of debris that will later rain down on surviving worlds. Only took a single low-angle collision to decide whether a world grows or diminishes. Yet even here, scientific uncertainty remains the precise number and nature of giant impacts that shape the terrestrial planets remain debated. The moon-forming impact is widely accepted, but the details of early bombardments leave room for interpretation. Only took the slightest change in initial conditions to alter an entire planet's collision history. Moving deeper into the chaos, the narrator senses paths where small worlds are flung entirely out of the solar cradle. Some are ejected into interstellar space, becoming orphan planets, drifting in the cold dark between stars. Others move into distant, elongated trajectories before being perturbed again. Only took the combined gravity of two planets to cast an embryo beyond the system's borders. A poetic detail emerges in the slow, cold departure of these castaways. Though they leave no mark behind, their departure carries a quiet sense of erasure, a reminder that not every body shaped in the early disk remains within the sun's light. Only took a long, slow drift outward to end a world story before it ever began. The narrator returns toward the inner solar system where Mars slowly forms at the edge of a region increasingly defined by instability. Mars itself is smaller than Earth or Venus, because the gravitational stirring beyond its orbit reduces the supply of accretable material. The scientifically accepted explanation is that Jupiter's perturbations depleted mass in the region, where Mars formed, leading to a smaller final planet. Only took the presence of a giant to soften the growth of a world. This thinning of material marks the boundary of the planet that should have existed, the one whose orbit would have formed between Mars and Jupiter had the region remained calm. But the narrator senses only turbulence and scattering here. Embryos collide too violently to merge. Orbits cross too frequently to allow accumulation. Jupiter's resonances too efficiently empty the region. Only took the rhythm of a giant planet's orbit to prevent the quiet shaping of a new world. A scientific uncertainty rests calmly at the edge of this region. Some simulations propose that an additional early planet, roughly Earth-sized, may have formed and later been ejected or collided with another embryo. Others suggest no such world ever reached substantial size. The difference lies in chaotic outcomes that diverge after billions of calculations. Only took one simulated encounter to determine whether a world grows or disappears. The narrator remains neutral, observing without assumption. What matters is the physics scattering is constant resonances, pervasive collisions, unpredictable. This dynamic landscape ensures that some paths lead to survival, and others to dissolution. Only took the interplay of countless small forces to decide which orbits endure. As the section draws to its quiet close, the narrator lingers in the heart of this gravitational turbulence. The young sun glows softly through the dusty haze. Embryos trace their unstable paths. Dust swirls. The region between Mars and Jupiter remains restless, shaped by interactions that prevent a planet from forming. And in this tranquil observation, the story of the planet that should not exist, not myth, not invention, but the scientific silence left by orbital dynamics, settles gently into place. The narration moves outward now, leaving behind the scattered pathways of young planetary embryos and drifting into the wide, quiet corridor that stretches between Mars and Jupiter. Here, the guiding sensation becomes the stillness of a region shaped not by absence alone, but by a long interplay of growth disruption and gravitational restraint. This is the space that holds the asteroid belt, not a remnant of a destroyed world, but the scientifically accepted relic of material that never quite became one. The fact grounding this moment is clear. The total mass of the asteroid belt is far too small to have ever formed a planet amounting to less than 1,000th of Earth's mass, dispersed across millions of bodies whose orbits remain dynamically excited. Only took the slightest tug from a distant giant to keep a world from growing in this corridor. The narrator drifts through the belt's inner edges where rocky bodies scatter across paths that shimmer with reflected light. These asteroids vary in size from meter-scale fragments to large bodies hundreds of kilometers across. Their surfaces are scarred, irregular, and ancient, shaped by billions of years of collisions. A poetic detail emerges in the way sunlight glints off their jagged faces, not sharply, but with a soft, dusty sheen created by layers of regolith that have accumulated over eons. Only took grains of shattered stone to coat these wandering rocks with the memory of every impact they've survived. Yet a scientific uncertainty rests gently across this region. Although resonances with Jupiter explain much of the belt's depletion, the precise distribution of different asteroid families hints at a more complex history involving early migrations of planetary bodies. The NIS model and its successors propose that Jupiter and Saturn once moved through the disk-altering conditions in ways still being studied. Only took the small wanderings of giant planets to shape the future for millions of smaller ones. As the narrator drifts deeper, the belt reveals its subtle structure. Gaps appear, the Kirkwood gaps, where orbital resonances with Jupiter remove asteroids over time. These gaps are not empty because bodies were destroyed, but because resonant gravitational pulls gradually move any object entering them into destabilizing orbits. Only took the rhythmic tug of a giant planet to carve invisible notches into a region otherwise full of drifting stone. The narrator hovers near one such gap, watching how asteroids on both sides maintain their distances as if held apart by an unseen pattern. These resonances create pathways where no planetesimal can remain stable for long, making the assembly of a larger world impossible. Only took the repetition of orbital timing to keep this region in perpetual fragmentation. Beyond the gaps, clusters of related asteroids form families' bodies sharing similar compositions and orbital characteristics, likely created by ancient collisions. Some families contain many members, others consist of only a few. A gentle observation arises: the solar system keeps its history not in written records, but in the distribution of stones orbiting a star. Only took the slow drift of fragments to preserve stories of collisions older than Earth's continents. Moving quietly through these families, the narrator senses the belt's diversity. Carbonaceous asteroids rich in organic materials and water-bearing minerals drift in the outer belt. Silicate-rich bodies populate the inner regions. Metallic asteroids, remnants of once molten worlds that failed to assemble, fully reveal cores exposed by long-ago impacts. Only took the faint difference in temperature across this corridor to separate its materials into three great classes, yet the scientifically grounded absence remains unmistakable. Despite the presence of material, the region lacks the mass and the calm necessary for a planet to form. Jupiter's gravity stirs orbits too strongly, increasing collision speeds and reducing the likelihood of gentle mergers. Over time, high-velocity impacts grind bodies down rather than building them up. only took slightly too much orbital excitement to transform growth into perpetual attrition. A poetic detail emerges in the dust that fills the belt. Microscopic particles drift between asteroids, forming a faint zodiacal glow, visible from Earth during certain seasons. This glow is not a remnant of a ruined planet, but an ongoing whisper of collisions happening continuously across the belt. Only took the grinding of ancient stones to produce a glow carried across the inner solar system. The narrator moves outward, following the belt's transition from rocky to icy as distance from the sun increases. Temperatures drop. Volatiles rise in abundance. The outer belt approaches a boundary where icy bodies begin to dominate, yet here too no planet forms. Each region of the belt carries the same signature, enough material to shape worlds, but not enough stability to let one thrive. Only took a small shift in gravitational balance to hold this corridor in a state of suspended potential. A quiet scientific mystery lingers why Mars at the inner edge of this region formed smaller than Earth and Venus. Current models suggest Jupiter's influence truncated the material available to Mars, but the precise details continue to evolve as simulations improve. Only took the subtle presence of a distant giant to sculpt a world that grew only part way. Drifting softly through the middle regions of the belt, the narrator senses the layered age of this corridor. Each asteroid holds records of early solar system processes. Some contain minerals formed in warm aqueous environments within once molten parent bodies. Others contain pre-solar grains untouched since before the sun existed. The belt is not a graveyard of a broken world, but a museum of incomplete history's bodies that began to grow but were never given the conditions to evolve further. Only took the long patience of cosmic time to keep these fragments frozen in their earlier states. Beyond the largest asteroid, Ceres Vesta Pallas Hygiea, the belt becomes sparser. These dwarf planet-like bodies approach the threshold of differentiation, forming layered interiors before growth ceased. They represent the closest this region came to producing a world. Only took a slight increase in mass to let these bodies cross from fragments into planets, yet the system never provided it. The narrator moves slowly past Ceres, sensing the quiet irony that it is nearly spherical, possessing a differentiated interior and even potential brine-driven geological activity, yet still far too small to become the missing world implied by orbital dynamics. Only took 0.5% of Earth's mass to hold back the formation of a new world. At the outer edge of the belt, the narrator drifts across the boundary, where resonances with Jupiter grow stronger, scattering bodies outward or inward. This region marks the transition to a space shaped even more by migration, scattering and loss. Here, the influence of Jupiter and Saturn creates a gravitational corridor that feeds bodies toward the inner solar system as meteorites or outward into the cold reaches beyond Neptune. Only took the gravitational breath of two giants to shape the flow of debris across billions of years. The belt as a whole stands as a stable yet dynamic record of what could not form the planet, whose absence structures the inner solar system from the start. The narrator senses the quiet truth. The belt is not an aftermath, but a prevention, a region defined by what gravitational dynamics forbid. Only took the enduring presence of Jupiter to ensure that the corridor between Mars and Jupiter remains forever a collection of fragments. As the narrator drifts beyond the last major asteroid, the belt thins into isolated bodies separated by vast distances. The silence deepens, the dust grows faint, the light softens. This corridor, shaped by incompleteness, opens into the wider outer solar system, where migration, scattering and ancient resonances will reveal new layers of the story. And somewhere within this smooth transition lies the subtle outline of the planet that should not exist, a world unformed not through catastrophe, but through the quiet, persistent influence of gravity acting over time. Only took a gentle imbalance carved in the earliest days of the solar system to define a mystery that endures. The narration moves onward without a break, drifting past the last thinning stones of the asteroid belt, and into a region shaped more by possibility than by form. Here, at the quiet edge where the belt gives way to wider space, the guiding sensation becomes contemplation of a world that never emerged. Not a lost planet, Not a destroyed world, but a body that physics would not allow to grow. This is the silence of the planet that wasn't the scientifically grounded absence carved into the solar system's plan by orbital dynamics mass distribution, and the unyielding presence of Jupiter. The fact grounding this moment is simple. The material in the asteroid belt never gathered into a planet, because Jupiter's gravitational influence kept collision velocities too high for accretion. Only took the distant pulse of a giant planet to break the chain of growth at its earliest links. The narrator glides gently across this region, where collisions have shaped every surface for billions of years. The fragments that remain from dust-sized particles to dwarf planet-scale bodies reveal the imprint of a history full of impacts, shattered crusts, excavated basins, irregular outlines preserved in vacuum. Yet the space around them feels strangely quiet, as though the region carries not the memory of violence, but the echo of incomplete formation. Only took the absence of a stable orbit to leave behind a system of fragments instead of a single world. A poetic detail emerges in the spacing of the larger bodies. Though millions of smaller fragments drift between them, the handful of largest asteroids remain like luminous markers in a sea of emptiness, bright enough to reflect the sun's distant light, steady enough to trace centuries-old patterns across the night sky, quiet enough to remind observers on Earth that even incomplete worlds hold their own kind of beauty. Only took a slight increase in diameter to turn a fragment into a place with internal layers, ancient water, and hints of frozen atmospheres. Yet even with this beauty, a scientific uncertainty lingers gently over the corridor. If the early solar system had arranged its mass slightly differently, would a planet have formed here after all? Some models suggest that without Jupiter's early migration, the belt could have grown into a Mars-sized or Earth-sized world. Others propose that the belt's initial mass was never high enough for planet formation even with perfect calm. Only took a few million years of early orbital shifts to erase the possibility of a stable world altogether. As the narrator drifts deeper into the region, the remaining planetesimals resemble the beginnings of worlds that never fully took shape. Some show differentiation, a sign they once grew warm enough for internal melting, separating metal cores from silicate mantles. These bodies approached the threshold of worldhood before their growth was halted. Only took the failure of one more accretion event to freeze them forever in their incomplete state. One such body, Vesta, displays vast troughs carved by ancient impacts. Its basaltic surface reveals a world that began volcanic activity before its growth stalled. It carries the calm irony that a planet's geological stirring can begin even in an object too small to become a full world. Only took a short-lived radioactive heat source to ignite volcanic motion on a fragment that would never join a larger world. Another body, Ceres, holds water-bearing minerals, hydrated clays, and hints of ancient brines beneath its crust. It represents the closest this region came to forming a stable, spherical, planet-like world, yet even Ceres contains far too little mass to dominate its surroundings. Only took a few missing orders of magnitude in material to keep Ceres from becoming the planet implied by orbital space. Drifting outward, the narrator senses the belt's shifting gravitational harmonics. Secular resonances, mean motion resonances, and chaotic zones, shaped by Saturn's presence, weave through this region like faint geometric patterns. Each resonance carves out trajectories where no planetesimal can remain for long. Only took the layered rhythms of 2 or 3 distant giants to prevent any one body here from reaching critical mass. The absence of a planet takes on a more precise tone. This region does not merely lack the mass to form a world, it actively removes mass through collisions and gravitational scattering. Over billions of years, fragments have been ground down, scattered inward toward the sun as meteorites, or flung outward into the distant reaches of the solar system. Only took the grinding of time to reduce mountains to pebbles, and pebbles to dust. A poetic detail arises in the dust itself. Fine grains drift through the region in soft arcs, tracing faint halos only visible when sunlight scatters through them at the right angle. From Earth, this dust contributes to the zodiacal light, a pale triangular glow rising from the horizon just before dawn or after sunset. Only took pulverized remnants of incomplete worlds to paint a glow across the inner solar system's twilight sky. Yet even in the quiet beauty, the narrator senses subtler scientific questions that remain unresolved. How much mass did the belt contain initially? Did Jupiter migrate inward early in the solar system's history, stirring this region before sweeping back outward? How many large bodies failed to survive the early chaos? Only took the loss of a few key pieces of evidence to leave these questions open across decades of research. The corridor itself stands as a reminder of gravitational constraints older than any planet. Every body here moves in orbits shaped by the doubled influence of the Sun and Jupiter. Eccentricities remain moderate, inclinations vary, instability persists at the edges. Even after billions of years, the region has not settled into calm. Only took a giant planet's persistent resonance patterns to keep this space forever restless. The narrator drifts toward the region's midpoint where a planet might theoretically have existed, one with an orbital distance around 2.7 astronomical units, with mass enough to dominate planetesimals around it, with gravity strong enough to clear its orbit. But the space is empty. No such world has ever orbited here. Instead, Ceres, Pallas Vesta and Hygieia trace incomplete arcs. Each hints at what could have been but was prevented by the physics that sculpted the early solar system. Only took a single giant planet forming too early to erase the entire path toward another terrestrial world. And still the belt remains. It survives as a partially assembled archive fragments of heated interiors, primordial dust, hydrated minerals, basaltic crusts, metallic cores. The missing world is written into these fragments not as fiction, not as myth, but as a geologic truth. This region holds the ingredients of a planet, yet not the mass, not the calm, not the timing required for one to exist. Only took the slightest imbalance in early dynamics to determine that the solar system would have 4 terrestrial planets, not 5. As the narration prepares to move farther outward, the silence of the unformed world lingers softly behind. Nothing dramatic occurs, nothing breaks, nothing grows. The region simply remains what it has always been, a corridor shaped by absence, structured by resonances, and filled with the remnants of a world that should not and could not exist. The narration drifts outward into the vast gravitational influence of Jupiter, sensing how the presence of a single giant shapes the destinies of countless smaller worlds. Here the guiding sensation becomes the quiet weight of a planet whose mass alters everything around it, not through violence or dramatic upheaval, but through steady, unbroken gravitational pressure that defines the architecture of the solar system. The scientifically accepted fact grounding this moment is that Jupiter contains more than twice the mass of all other planets combined, and its gravitational reach sculpts orbital resonances, clears regions of debris and controls the long-term stability of countless bodies. Only took one giant orbiting 5 times farther from the Sun to carve the entire structure of the inner solar system. The narrator glides beneath Jupiter's broad shadow, moving through the regions where its resonances send steady pulses of gravitational energy across millions of kilometers. These resonances repeating patterns where the orbital period of a smaller body syncs with that of the giant, create rhythms that shape space like invisible geometric sculptures. A poetic detail emerges in the way these resonances form subtle harmonic corridors, each with its own orbital tempo, each carving out long arcs of space where small bodies can remain stable or be slowly stirred into new paths. Only took the quiet heartbeat of a giant world to define where smaller worlds may exist. Yet a scientific uncertainty lingers softly around Jupiter's early history. Models suggest the giant may have migrated inward during the solar system's youth, perhaps reaching as close as Mars's current orbit, before drifting outward again through interactions with Saturn. This hypothesized path, called the Grand Tack, seeks to explain the small size of Mars and the mixed composition of the asteroid belt. But its exact extent remains debated. Only took a few million years of unnoticed migration to leave scientists pondering whether Jupiter once passed far closer to the Sun. The narrator moves through the wake of this hypothetical migration, imagining not a dramatic journey, but the slow drift of a gas giant through a disk of dust and planetesimals. Even a slight inward motion would have scattered materials in the terrestrial zone, disrupting growth and reshaping the mass distribution. Only took the subtle shift of a giant planet's orbit to determine which embryos survived and which dissolved into wandering debris. Now resting in its current position, Jupiter continues to send resonances inward. The 3-1 resonance, the 5-2, the 7-3 each creates a destabilizing zone in the asteroid belt where no planet can form. Small bodies entering these regions experience periodic gravitational nudges that increase their eccentricities gradually over time. Eventually they are ejected, collide with other bodies, or fall inward toward the Sun. Only took the repetition of a simple orbital rhythm to shake a million rocks from their paths. A poetic detail appears in the dispersal of dust across these resonant pathways. As small fragments are excited into higher eccentricities, they leave trailing arcs of dust that spiral inward, contributing to the faint zodiacal light visible from Earth. Only took the soft scattering of unseen particles to create a glow across the dawn sky. Beyond the asteroid belt, the narrator approaches Jupiter itself. The planet's massive presence alters the flow of gas in the early disk-shaping pressure maxima, where pebbles may have accumulated or stalled. These pressure traps may have accelerated Jupiter's growth, feeding the core that formed before the gas dissipated. Only took one well-positioned pressure bump to feed the making of a world larger than all the rest combined. The giant's early formation also halted inward migration of gas-driven wave patterns, protecting the inner solar system from runaway accumulation. Without Jupiter's early presence, terrestrial planets might have grown larger or migrated inward themselves. Only took the early birth of a giant planet to keep Earth from becoming a different kind of world entirely. Yet another scientific uncertainty rests here: how quickly Jupiter formed, whether its core grew through pebble accretion or planetesimal collisions, and how much early turbulence shaped its final size. Researchers model scenarios where Jupiter forms extremely rapidly or through slower layered processes. Only took an uncertain timeline of growth to leave room for multiple interpretations. The narrator senses how Jupiter's gravitational influence extends far beyond the belt. Its resonances sculpt comets, shape Trojan asteroids into leading and trailing swarms, and even affect the distribution of material in the inner Kuiper Belt. Only took the presence of a single massive body to stretch its reach across entire regions of space. The Trojan swarms, millions of bodies sharing Jupiter's orbit, drift softly in the narrator's path. These clusters occupy the L4 and L5 Lagrange points, where the gravitational pull of Jupiter and the Sun balances perfectly with orbital motion. The stability of these points allows debris to accumulate and remain for billions of years. Only took the geometry of gravitational equilibrium to cradle entire populations of ancient asteroids. A poetic detail emerges in the chaotic surfaces of these Trojans. Many are carbon-rich, carrying dark coatings that absorb sunlight. Their muted tones contrast with the bright whiteness of Jupiter's clouds far below, forming a visual reminder that even bodies sharing the same orbit can carry vastly different compositions. Only took one world's position to gather two entirely different kinds of primordial rubble. The narrator drifts toward the outer boundaries of Jupiter's sphere of influence, where the giant's gravity transitions from dominating local orbits to merely perturbing those of distant bodies. It is here that the giant interacts indirectly with Saturn, establishing resonances that govern the broader evolution of the outer solar system. Only took the subtle handshake between two giants to guide the migrations of many smaller worlds. These interactions seeded waves of scattering far beyond the asteroid belt, influencing the trajectories of objects that would later inhabit the Kuiper Belt, the scattered disk, and even the Oort cloud. The narrator senses the first gentle pulses of these distant migrations, not dramatic expulsions, but slow-moving rearrangements unfolding over tens of millions of years. Only took a slight adjustment in the orbits of two giant planets to send icy bodies drifting into wider, colder pastures. As the narrator continues outward, the gravitational dominance of Jupiter fades into the background, yet its influence remains woven into the structure of every orbit nearby. The missing planet between Mars and Jupiter is not a mystery of destruction, but a simple consequence of this overwhelming mass. Jupiter did not break a planet, it prevented one. Its presence ensured that the corridor between Mars and Jupiter could never accumulate the calm, the mass, or the stability needed for planetary assembly. Only took the quiet, persistent resonance of a giant to define the solar system's inner architecture for billions of years. Moving finally to the far edge of Jupiter's realm, the narrator senses how the path ahead leads toward the zone, where scattered icy worlds begin the first hints of the outer solar system's colder complexity. Jupiter remains behind like a massive punctuation mark in the solar system's grammar, shaping the syntax of everything that follows. Only took the presence of a giant to give structure to the space where fragments, migrations, and future mysteries quietly unfold. The narration drifts outward, leaving the vast domain of Jupiter behind, and entering a quieter, more tenuous region where the solar system's early migrations sent countless smaller worlds into exile. Here, the guiding sensation becomes the silent motion of planetary embryos and large planetesimals that once wandered freely through the protoplanetary disk, but were eventually pushed into the deep outer regions or expelled entirely. The scientifically accepted fact grounding this scene is that during the solar system's early instability, the period of giant planet rearrangement and orbital scattering, many planetary embryos were displaced from their original orbits. Some captured into distant reservoirs, others lost into interstellar space. Only took the shifting paths of giant planets to scatter embryonic worlds far beyond their birthplaces. The narrator moves through a region where these displaced bodies drift with quiet composure. Their orbits are elongated, inclined, and only loosely bound to the sun. Some travel on long loops that take centuries to complete. Others circle more quickly but far from the stability of the inner system. The space here feels sparse, yet the trajectories of these bodies form soft, interlaced curves, a geometrical record of interactions long past. Only took a brief gravitational encounter millions of years ago to set a worldlet drifting on a path thousands of years long. A poetic detail arises in their surfaces. These planetary embryos, though too small to become full planets, hold frozen textures shaped by early heating and cooling. A few retain metallic cores, others show evidence of ancient differentiation, hints that they once grew warm enough for internal layers to form before scattering halted their growth. Only took a few tens of kilometers of radius to begin imitating the internal architecture of much larger worlds. Yet a scientific uncertainty lingers. How many such bodies once existed remains unknown. Simulations produce varying numbers, some suggest dozens, others hundreds, depending on assumptions about the early disk's density and how quickly Jupiter and Saturn migrated. Only took a slight change in disk turbulence or initial mass to alter the entire census of lost planetary embryos. As the narrator drifts farther, these exiled bodies grow more diverse. Some originate from the region where Earth and Venus formed. Others come from the asteroid belt's failed zone. A few may even be fragments from collisions between early embryos. Their compositions span metallic, rocky, and icy. Only took a single collision in the inner system to send a rocky core fragment drifting into the cold. The giant planets, Jupiter, Saturn, Uranus, and Neptune, play distinct roles in shaping these paths. During their early migrations, their resonances swept across wide stretches of space, destabilizing orbits and sending bodies spiraling outward. Some of these small worlds were captured temporarily by giant planets, orbiting them as irregular moons before being ejected once again. Only took a brief gravitational handshake to trap a fragment for a cosmic moment before letting it drift away. A poetic detail emerges in the orbits of these captured moons. Many of Jupiter's and Saturn's irregular moons move in retrograde motion, their inclinations marking them as former wandering planetesimals caught by chance. They represent the silent survivors of early chaos bodies that found temporary refuge in the gravitational basins of giants. Only took a timely encounter with a massive planet to transform a nomad into a permanent satellite. Yet most of the exiled planetary embryos did not remain as moons. Instead, interactions with the giants sent them on new trajectories, some outward toward the Kuiper Belt, others into elongated orbits that cross the paths of the giant planets, and still others into escape routes out of the solar system entirely. Only took a near miss with Jupiter or Saturn to accelerate a worldlet fast enough to leave the Sun forever. Drifting beyond Saturn's orbit, the narrator enters the region where many scattered bodies eventually settled into temporary or permanent populations. Some became centaurs, icy rocky bodies with unstable orbits between Jupiter and Neptune. Their lifetimes in these zones are limited, sometimes only a few million years, before gravitational encounters send them inward as comets or outward to colder zones. Only took a slight nudge from a distant planet to turn an icy traveller into a short-lived visitor of the inner solar system. A scientific mystery drapes gently across this region. The precise contribution of lost embryos to present-day centaur populations remains uncertain. While many centaurs come from the trans-Neptunian region, some may trace their origins to bodies scattered outward during early planetary migrations. Only took the overlap of model predictions to keep the origin stories of these fragments partly unresolved. The narrator observes how these scattered bodies interact with Neptune, whose gravitational field defines the boundary between unstable intermediate orbits and the more structured domains of the Kuiper Belt. Neptune's resonances form quiet corridors where some bodies become trapped, stabilizing their paths for millions of years. Others drift past resonance boundaries and are thrown into chaotic zones that redirect them again. Only took the subtle shift of a resonance boundary to capture an object for a geological epoch. Moving into the realm of scattered disk objects, the narrator senses the characteristics of distant bodies that travel on extremely elongated orbits, diving close to Neptune before sweeping far into the outer darkness. These pathways reflect ancient perturbations where a planetary embryo or large planetesimal interacted strongly with the migrating giants. Only took one strong encounter to fling a once warm body into a region where sunlight arrives as a faint memory. A poetic detail appears in the way ice on these bodies sublimates slowly when they approach the sun, releasing faint, thin atmospheres that disappear again as they drift back into the cold. Their surfaces bear layers of organic rich compounds reddened by cosmic rays and preserved in the vacuum. Only took billions of years of distant sunlight to tint these surfaces into hues unseen on any inner planet. Yet even here uncertainties remain. Did all these bodies originate in the early solar system, or were some captured from interstellar space? Recent discoveries like Oumuamua and Borisov remind scientists that interstellar planetesimals do occasionally pass through star systems. Some may even be captured. Only took the passage of a wandering interstellar fragment to raise questions about the system's earliest acquisitions. Drifting farther outward, the narrator reaches the transitional space where scattered objects become detached, moving along stable but distant orbits far beyond Neptune's influence. Bodies like Sedna and 2012 VP-113 travel paths with enormous perihelia suggesting perturbations not easily explained by interactions with known planets. Only took one early gravitational push perhaps from a passing star during the Sun's birth cluster to place these bodies on orbits that barely remember the inner system at all. A poetic image arises in Sedna's long journey. It takes more than 10,000 years to complete one orbit, drifting into the deep cold before curving gently back toward the faint warmth of the Sun. Only took a slow loop through darkness to embody the calm loneliness of distant space. But even here, another scientific uncertainty emerges softly. The mechanism that placed these bodies onto their distant orbits remains debated. Some models cite early stellar encounters, Others propose interactions with now-vanished planetary embryos. A few invoke the distant influence of an unseen mass in the far outer system. Only took the long memory of orbital mechanics to hold a mystery that models continue to explore. As the narrator remains suspended in this region of exiled worlds, the theme becomes clear without needing to be spoken. The solar system once held far more bodies than it does today. Some merged, some shattered, some became moons, many were scattered outward, and countless others were lost to the interstellar dark. Only took the shifting geometry of the early solar system to turn possible worlds into wanderers. The narrator hovers in this quiet field of distant icy travellers, sensing the slow movements that define their orbits. Nothing here grows, nothing returns to its original state. These worlds drift silently, carrying the memory of gravitational encounters older than any planet's final shape. And within their paths lies the deeper truth of the planets that should not exist before emptiness settled between Mars and Jupiter. This scattering, this gentle exile of early embryos shaped the architecture that made that absence necessary. Only took the whisper of early orbital chaos to create a space now remembered only through fragments, trajectories, and silence. The narration moves farther outward, leaving behind the scattered intermediaries, and drifting into a region where the light of the sun softens into a pale wash over ice-bound bodies. Here the guiding sensation becomes the wide, quiet geometry of the Kuiper Belt, a realm formed not from shattered potential, but from icy beginnings that never sought to become worlds in the inner sense. The scientifically accepted fact grounding this moment is straightforward. The Kuiper Belt is a vast population of icy planetesimals left over from the formation of the solar system, shaped by the migration of Neptune and the resonances carved into space by the giant planets. Only took the slow outward drift of a distant giant to sculpt a frigid ring of primordial objects. As the narrator drifts through the inner Kuiper Belt, the bodies encountered appear small and cold, their surfaces coated with frozen methane nitrogen and water ice. These objects spin slowly, some in elongated orbits, others in near-circular paths. The region is thick with ancient chemistry, each body carrying molecules preserved at temperatures so low that even volatile compounds remain stable for billions of years. A poetic detail emerges in the sunlight itself, not bright, not warm, but a thin silvery glow that reflects faintly off crystalline frost. Only took the softest touch of distant light to reveal the multicoloured patches of tholins that redden these icy surfaces. Yet a scientific uncertainty lingers gently across the Kuiper Belt structure. Though models explain much of its dynamical architecture, the precise sequence and timing of Neptune's migration remains debated. Some propose smooth outward motion, others argue for a more abrupt step-like path shaped by planetary instabilities. Only took a slight change in the migration curve to alter the entire distribution of outer belt objects. The narrator moves into regions where resonances dominate. The 3-2 resonance, home to the Plutinos, hosts objects like Pluto, whose orbits remain in a long-term stable configuration, protected from close encounters with Neptune by the rhythm of gravitational timing. These objects complete 2 orbits of the Sun for every 3 of Neptune's, a simple ratio that preserves orbital harmony. Only took the regular cadence of one giant timekeeper to shelter hundreds of smaller worlds from destabilization. A poetic detail unfolds in the way Pluto and its resonant companions dance through the outer system, retreating from Neptune's path as if following an unspoken rule of distance. Their orbits cross Neptune's orbit on paper, yet they never collide, a reminder that resonance creates order where chaos might otherwise reign. Only took the gentle enforcement of orbital music to maintain peace in the frozen dark. Farther outward, the narrator observes the classical Kuiper Belt objects' bodies with stable, roughly circular orbits that were not captured into resonances. These objects are thought to have formed near their current locations, surviving planetary migrations with minimal disturbance. Their orbits trace a smooth band around the Sun, a relic of the primordial disk's outer layers. Only took a relative distance from Neptune's disruptive resonance zones, to keep these worlds in quiet, near-original positions. Yet even this peaceful population contains hints of deeper complexity. The classical objects divide into cold and hot populations, the cold belt, with low inclinations and smaller sizes, and the hot belt with more varied inclinations and larger bodies. The scientifically accepted explanation links these differences to Neptune's migration, but the exact details remain unsettled. Only took the giant subtle steps across the outer disk to give rise to two populations with distinct dynamical memories. The narrator drifts near some of the larger Kuiper Belt objects, Haumea, Makemake, Quaoar each, carrying the calm irony of being nearly planetary in their roundness, yet too small to clear their orbits. Their compositions vary: crystalline ice on Haumea's surface, methane frost on Makemake, hints of ancient atmospheres escaping into the cold. Only took the difference of a few million kilometers in formation location to determine whether a world becomes rich in methane or barren of volatiles. Beyond these bodies, the Kuiper Belt begins to thin. Objects become sparser and dynamical excitation becomes more pronounced. Here lie many bodies influenced by Neptune's resonances during its outward migration, pushed into higher inclinations and eccentricities. Only took a slow gravitational shove from the migrating giant to lift these icy worlds into tilted, elongated paths. A poetic detail appears in the shadows cast by these bodies as they rotate. Their long elongated shapes stretch thin beams of reflected light across the surrounding dust, creating faint streaks that disappear into the darkness. Only took a turn through cold space to cast a beam faint enough to vanish almost instantly. The narrator senses the outer boundary of the Kuiper Belt approaching the space where the belt gives way to the scattered disk, a region shaped by more energetic encounters with Neptune. Here, icy objects travel on orbits that take them far beyond the Kuiper Belt's classical bounds, often returning near Neptune's orbit only to be flung outward again. Only took a close passage by a cold giant planet to send an object hundreds of astronomical units into the dark. Scientific uncertainty grows stronger here. Some scattered disk objects appear too distant for Neptune alone to have placed them on their paths, suggesting early encounters with passing stars or interactions with long-lost planetary embryos. Only took one stellar neighbour drifting through the Sun's birth cluster to disrupt an outer orbit for billions of years. The narrator drifts slowly past objects whose surfaces may never have warmed above a few tens of degrees above absolute zero. Their compositions preserve some of the earliest chemistry in the solar system, including hypervolatile ices like nitrogen, carbon monoxide and methanol, locked away in forms untouched since formation. Only took temperatures colder than liquid nitrogen to store chemical stories older than any planet. As the narrator follows the thinning population, the Kuiper Belt's faint geometry becomes clear, a truncated disk, shaped by migration resonance, scattering and loss. It is not a leftover of a broken world, nor the cradle of a missing planet. Instead, it is the quiet archive of what the outer solar system once was, a region where growth slowed, formation stalled, and interactions with giant planets defined every orbit. Only took the slow migration of Neptune to sculpt the space where icy worlds linger in stable survival. The narration lingers at the belt's edge, sensing how the environment grows colder and the distances widen. The missing world, the planet that should not exist, is not here. Yet the outer realms carry the same imprint of gravitational shaping that created the silence between Mars and Jupiter. Only took the sweeping motions of giants to place worlds where they persist and prevent worlds where they cannot form. As the narrator prepares to move beyond the Kuiper Belt, the space ahead grows emptier, quieter, and older. The story continues in the orbits that do not fit neatly within the belt structure. The strange, inclined, elongated paths of trans-Neptunian bodies that hint at influences yet to be fully understood. Only took the persistence of unanswered questions to open the next region of the solar system's quiet architecture. The narration moves beyond the thinning outer edge of the Kuiper Belt into a region shaped not by orderly resonances but by quiet, lingering strangeness. Here the guiding sensation becomes the slow drift of bodies, whose paths do not align with the neat geometry of classical or resonant Kuiper Belt objects. These trans-Neptunian objects with unusual orbits highly inclined, elongated, or clustered in unexpected ways form a subtle frontier where the solar system structure stretches into uncertainty. The scientifically accepted fact grounding this moment is that numerous objects beyond Neptune exhibit orbital properties not easily explained by the known planets alone, such as extreme perihelia, high inclinations, or clustered arguments of perihelion. Only took a few distant orbits refusing simple patterns to raise questions about the system's early architecture. The narrator drifts alongside one such object, a body with a path dramatically tilted relative to the solar system's usual plane. Its orbit dips below and rises above the ecliptic, carrying it far out of alignment with ordinary Kuiper Belt trajectories. Surfaces on these bodies often hold deep reddish hues, the colours of complex organic ices altered by cosmic rays over billions of years. A poetic detail emerges in the contrast between their frozen surfaces and the smooth plane of planets far inside a slow, lonely arc cutting across a flattened system. Only took the tilt of an orbit to express a history untouched by the calm geometry of the inner solar system. Yet a scientific uncertainty lingers softly. Here are these inclinations the product of Neptune's ancient migration, or do they signal interactions with massive planetesimals now gone? Some models show that as Neptune moved outward, it could have scattered distant bodies into such extreme angles. Others suggest early stellar encounters in the Sun's birth cluster may have stirred these orbits. Only took a passing star drifting too close to pull entire populations into new orbital inclinations. Moving farther outward, the narrator encounters bodies with extreme eccentricities. Their orbits stretch like long, thin ellipses, bringing them occasionally within the realm of Neptune's influence, before sending them hundreds of astronomical units into the cold. These are objects of the scattered disk, but some extend beyond even that definition, belonging to the category of detached or extended objects, whose orbits do not intersect Neptune's at all. Only took one early gravitational push in the right direction to lift these worlds permanently beyond the giant planet's reach. A poetic detail arises in the faint sunlight glinting off their icy crusts. Out here, the sun is only a bright star casting a soft, distant glow rather than warm illumination. Shadows fall with sharpened edges but minimal contrast. Each body rotates slowly at surface, sometimes mottled by organic crusts, sometimes smooth with frozen nitrogen or methane. Only took the cold of distant space to preserve thousands of square kilometers of frost for billions of years without change. As the narrator drifts among these isolated paths, another scientifically accepted pattern appears. Certain extreme trans-Neptunian objects show clustering in the orientation of their orbits, specifically in the argument of perihelion longitude, of ascending node and other orbital elements. While the dataset remains small, the clustering appears statistically unusual when compared with random distributions. Only took the alignment of a few distant orbits to suggest a gentle whisper of a shared origin or unrecognized influence. Yet a scientific uncertainty rests at the heart of this clustering. Some researchers argue it may indicate the gravitational influence of an unseen distant mass, the proposed Planet 9, while others contend the clustering may result from observational biases or the limitations of current surveys. Only took a small-scale sampling of a vast region to make chance appear like pattern. The narrator remains still observing without conclusion. These distant objects simply travel their long, cold paths, whether grouped by some unseen force or merely by the incomplete reach of telescopes. Their motions unfold quietly over tens of thousands of years, too slow for human intuition, yet steady enough to leave measurable traces. Only took orbits lasting millennia to create patterns that seem intentional even if they arise from chance. Moving deeper into the realm of the extreme, the narrator approaches Sedna-like objects whose perihelia remain far beyond the gravitational reach of Neptune. These bodies never come close enough to be significantly perturbed by the known giants. Their orbits must have been shaped by something else, perhaps the early sun's nursery environment, or interactions with large planetesimals scattered outward in the solar system's youth. Only took one tug during the system's earliest million years to place a world on a path lasting 10 millennia. A poetic detail emerges in the sheer quietness of Sedna's orbit. For most of its journey, it drifts in darkness so deep that sunlight arrives as a whisper, illuminating its surface with only the faintest reflection. Ice on its crust remains undisturbed, untouched, unchanged. Only took the patience of deep time to shape a world that moves so slowly it seems almost still. As the narrator travels farther outward, the orbits encountered grow more unpredictable. Some bodies show inclinations reaching 70 or 80 degrees, others move retrograde, orbiting the Sun opposite the direction of the planets. While retrograde comets exist closer in retrograde trans-Neptunian bodies, are rare, hinting at violent or unusual histories. Only took one complex interaction with a passing body to flip an orbit backward relative to every major planet. Yet these odd orbits hold a scientifically grounded truth: the outer solar system retains dynamical memory of events that do not survive in the inner system. Closer to the Sun, collisions, migrations, and gravitational influences erase old signatures. Out here, where interactions are rare, ancient perturbations persist for billions of years. Only took the slower pace of distant space to preserve orbital fossils from the system's youth. The narrator glides toward an object whose orbit shows a perihelion distance of 50 astronomical units, too far for Neptune to shape directly. Its inclination is moderate, its eccentricity high. Such objects form a bridge between the scattered disk and the even more distant detached population. Only took a single gravitational encounter in the early solar system's chaotic infancy to shift its orbit from ordinary to extraordinary. A poetic detail appears in the silence of this region. With so few bodies spread across so vast a space, each object traces its orbit alone. There are no dense clusters, no bright families, no buzzing, dynamical neighbourhoods. Instead, the region feels like an archive of solitary trajectories. Only took the thinning of material at great distance to make every orbit feel like a quiet signature rather than a collective movement. Scientific uncertainty deepens further here. Some of these bodies may carry evidence of unknown gravitational influences, perhaps a rogue planetesimal, long since ejected, perhaps a transient stellar neighbour, perhaps a structure in the early gas disk that shaped their orbits before dispersing. Only took the vanishing of early evidence to leave modern scientists reconstructing the past from faint patterns in icy motion. The narrator drifts back slightly to observe the region as a whole. Even though thousands of such objects remain undiscovered, the few known paths show that the outer solar system is neither simple nor symmetrical. Its architecture includes complexities not predicted by early models, unexpected inclinations, detached orbits, elongated trajectories with perihelia far beyond Neptune. Only took the combined history of migration, scattering, and stellar birth environments to sculpt a realm filled with quiet irregularities. As the narrator prepares to move outward still farther, the impression left by this region becomes clear without needing to be spoken. These bodies are the first true hints of a solar system shaped not just by what exists, but by what once passed through, brushed against, or influenced the disk before vanishing. Only took the faint memory of interactions long forgotten to leave orbits that drift in slow, cold defiance of simple geometry. And somewhere beyond these paths, the story stretches into still more distant territory, where anomalies soften into mysteries and mysteries blend into the subtle, gravitational field that defines the outer frontier. The narration drifts even farther from the Sun, entering a region where the faint gravitational pulse of the inner solar system grows softer, and the orbits of distant bodies begin to reveal influences not immediately accounted for by the known planets. Here, the guiding sensation becomes the quiet question. Implied by these distant motions, the possibility that unseen patterns, unmeasured masses, or incomplete models subtly shape the architecture of the far outer system. The scientifically accepted fact grounding this moment is that certain trans-Neptunian objects exhibit orbital clustering unexpected perihelion distances or inclinations that cannot be fully explained by interactions with Neptune alone, prompting ongoing scientific inquiry into whether additional gravitational influences, early stellar encounters, or statistical biases might account for these features. Only took a few persistent irregularities to suggest that the solar system retains traces of forces not fully mapped. The narrator moves alongside one of these distant bodies, tracing its orbit as it drifts thousands of astronomical units from the Sun before curving slowly back inward. Its trajectory is elongated, its perihelion elevated far above Neptune's reach, its inclination tilted gently compared with the planetary plane. A poetic detail emerges in the long arc it draws across the deep sky, not dramatic, not swift, but a slow geometry carved across tens of millennia. Only took a single early perturbation to shape a path too wide and too cold for ordinary gravitational stories. Yet a scientific uncertainty lingers like a soft veil across this region. Whether these distant orbits reflect the presence of additional massive bodies or are simply artifacts of small number statistics remains actively debated. Some surveys detect clustering and arguments of perihelion among extreme trans-Neptunian objects. Others note that observational biases can create the appearance of patterns where none exist. Only took the limited reach of telescopes to make randomness resemble alignment. As the narrator drifts farther, the gravitational influence of Neptune grows weaker. The known planets no longer dictate the full structure of space. Instead, the region feels shaped by an interplay of distant tides, the collective gravity of the galaxy, the Sun's slow orbit around the Milky Way, and the faint imprint of early interactions during the solar system's birth in a dense cluster of forming stars. Only took the slow motion of a star through its galaxy to tug gently on the distant edges of its own system. A poetic detail appears in the distant darkness, where sunlight dims to a pale point barely strong enough to cast shadows. At hundreds of astronomical units away, the Sun resembles a bright lantern hung in a vast cold hall. Surfaces on distant objects remain so cold that volatiles freeze the moment they are exposed. Only took the faint warmth of one star to remain perceptible, even at distances where most of its energy feels like memory. Some extreme trans-Neptunian objects trace orbits that carry them tens of thousands of years between perihelion passages. During these long journeys, they approach regions where galactic tides subtly shift their inclinations or alter their distant aphelia. The scientifically accepted fact is that beyond roughly 2,000 astronomical units, the gravitational gradient of the Milky Way exerts measurable torque on the solar system's outermost bodies. Only took the slow pull of the galaxy to shape paths far too large for planetary influence alone. Yet another scientific uncertainty arises: the boundary where Neptune's dominance ends and galactic tides begin remains indistinct. Models vary widely depending on the initial conditions assumed for the early solar system's birth cluster, its size, density, and the proximity of neighbouring stars. Only took a slight change in that ancient stellar neighbourhood to alter the long-term evolution of distant orbits. The narrator glides near a body with an unusually high inclination, nearly perpendicular to the planetary plane. Its orbit calls to mind the Kozai-Lidov mechanism, in which a smaller body oscillates between high inclination and high eccentricity under the influence of a distant perturber. This mechanism has been invoked to explain some far-off paths, though evidence remains incomplete. Only took the slow mathematical dance of Kozai cycles to give rise to orbits that defy easy categorization. A poetic detail arises in the way these inclined bodies move through three-dimensional space. Unlike the flattened disk of the planets, they trace arcs above and below, dipping through the ecliptic like slow comets, held in elongated harmonic motion. Their paths resemble celestial breaths, rising, falling, pausing without urgency. Only took the tilt of a single orbit to reveal how the solar system is not confined to a plane but extends softly into depth. The narrator senses how these unusual orbits form a quiet transition between the known structure of the Kuiper Belt and the beginning of more speculative regions where gravitational signatures become faint and ambiguous. Some objects exhibit clustering not just in orientation but in semi-major axis. Others mirror each other's inclinations unexpectedly. Only took the repetition of a few orbital coincidences to inspire decades of modelling seeking unseen contributors. Yet scientific caution persists. Many researchers warn that present samples are too small, surveys too incomplete, detection biases too strong to draw firm conclusions. Some argue that the observed clustering will dissolve as new objects are discovered. Others maintain that statistical significance has already been achieved. Only took the addition of a handful of new discoveries to shift consensus from one possibility to another. Still, the shapes of these distant orbits remain calm reminders that the solar system's frontier is not an orderly edge but a gradient of gravitational memory. Each object carries a record of early events, the migration paths of the giant's bombardments by planetesimals, nudges from passing stars, and the slow shifting of the galactic tide. Only took the accumulation of countless faint influences to sculpt orbits that drift in soft defiance of simple patterns. The narrator drifts higher above the ecliptic, watching the distant objects move below like slow beads on invisible threads. Their long periods, their elongated loops, their tilts and offsets collectively form a quiet testament to the solar system's evolving past. Only took the patience of billions of years to transform chaotic beginnings into enduring yet peculiar orbits. As this region stretches outward toward the realm, where even rare objects become sparser, the narrator senses the emerging boundary between the trans-Neptunian domain and the still more distant territories regions defined not by any single planet, but by the combined influence of ancient interactions and the sun's slow journey through the galaxy. Only took the interplay of distant forces to create a frontier where the solar system structure becomes less a disk and more a spherical whisper of ancient motion. This is the space where gravitational questions grow quiet but not resolved, where objects become too sparse to define clear patterns, and where the possible hints of unseen influences begin to blur into the background of cosmic tides. Only took the fading density of distant bodies to usher in the next chapter, a region shaped less by what we know and more by what may have once passed through unseen. The narration drifts outward again, crossing a threshold where the familiar shapes of the Kuiper Belt and the scattered disk dissolve into something more diffuse, more ancient and more deeply imprinted by the earliest movements of the solar system. Here the guiding sensation becomes the slow fading of structure itself, a region where orbits stretch into emptiness and the distances between bodies grow so great that each one seems like an isolated thought suspended in the dark. The scientifically accepted fact grounding this moment is that beyond the structured trans-Neptunian region lies a transitional zone that leads eventually toward the inner Oort cloud, where bodies reside on vast, loosely bound orbits, shaped by past gravitational encounters with giant planets, early stellar neighbours, and the long-term tides of the Milky Way. Only took the faint pull of distant stars to begin the slow rearrangement of icy planetesimals into the sphere that lies beyond. The narrator drifts through this transitional region, sensing how the sparse population of distant objects becomes even sparser. Their orbits vary widely in inclination and eccentricity, no longer clustering around a single plane. Some move almost perpendicular to the ecliptic. Others drift retrograde. Many follow loops so elongated that their aphelia remain unknown. A poetic detail emerges in the fragile appearance of these trajectories, long, graceful lines, stretched across millions of kilometres, but traced by bodies that hardly move at all on human timescales. Only took the faintest nudge from a giant planet or a passing star to draw these orbits into shapes too wide for easy understanding. Yet scientific uncertainty drifts through this region like a quiet haze. The boundaries between the outer scattered disk, the detached population, and the inner Oort cloud remain indistinct. Some models define the beginning of the Oort cloud at 2,000 astronomical units. Others extend the boundary inward to a few hundred. Only took a subtle change in model parameters to shift an object from one category to another. As the narrator continues forward, the gravitational influence of the Sun diminishes gradually. The star remains the dominant force, but no longer overwhelmingly so. The galactic tide exerted by the mass of the Milky Way becomes perceptible, shaping the slow oscillations of distant orbits, altering their perihelia over millions of years. This tidal influence helps lift some bodies out of the planetary region, entirely giving rise to the vast sphere of long-period comet reservoirs. Only took the turning of a galaxy to co-author the motions of the solar system's most distant inhabitants. A poetic image arises in the way these bodies respond to the galaxy's pull. They drift upward and downward relative to the galactic plane, moving in cycles that take hundreds of millions of years to complete. Their motions resemble slow tides on a cosmic shore, rising and falling without sound. Only took the weight of the Milky Way's disk to bend the paths of icy travellers older than Earth. The narrator passes near a distant planetesimal, whose orbit shows perihelion far from Neptune, and aphelion drifting possibly into the realm where the Sun's influence yields to that of passing stars. Objects like this belong to no simple category, too distant to be shaped purely by the known planets, too close to be stable residents of the outer Oort cloud. Only took one early encounter, perhaps with a star that has long since vanished from the Sun's neighbourhood, to grant this icy body an orbit unlike any found closer in. A scientific uncertainty arises here, soft but persistent. How many early stellar encounters did the solar system experience in its birth cluster? Some models indicate several close passages within the first 100 million years. Others suggest only distant interactions. The shape of the inner Oort cloud depends heavily on these early events. Only took the difference of a few tenths of a parsec in stellar proximity to reorganize thousands of distant orbits. The narrator drifts farther toward a region where objects become nearly impossible to observe from Earth. Their faintness approaches invisibility, their distance is measured not in tens or hundreds, but in thousands of astronomical units. Yet their presence is inferred through models that reconstruct the solar system's formation. Only took the limits of present-day telescopes to render this region more theoretical than observed. A poetic detail appears in imagining these distant icy bodies illuminated by starlight so weak that a human observer could not distinguish it from darkness. Their surfaces remain unchanged since formation pristine archives of the early solar system, their ices still bearing the signatures of ancient chemical processes. Only took the cold of deep space to preserve molecular arrangements older than any planetary crust. As the narrator continues drifting outward, the orbits encountered appear to lean towards sphericity, rather than the flattened disk of the inner regions. This transition reflects how repeated gravitational nudges from stars and galactic tides gradually isotropize the distribution of distant bodies. Only took the slow smoothing effect of external forces to turn the outer solar system from a disk into a sphere. Yet scientific uncertainty remains about the precise shape and extent of the inner Oort cloud. Some models propose a toroidal or donut-like precursor structure before the full spherical Oort cloud emerges. Others suggest a more irregular form. Observations remain sparse. Only took the missing data of a region too distant for direct study to leave room for multiple plausible architectures. The narrator pauses near the quietest part of this transitional zone. Here distances are so great that the gravitational pull of the Sun feels soft, almost hesitant. Bodies orbit slowly, some taking tens of millions of years to complete a single circuit. Their motions carry the calm irony of worlds bound to the Sun yet barely feeling its presence. Only took a slight increase in distance for gravity to fade into a subtle whisper. Another poetic detail arises in the long shadows cast by these icy bodies, if shadows can be said to exist where sunlight is scarcely distinguishable from darkness. The shadow is not a line, but a region of infinitesimal dimming so subtle that it would pass unnoticed even to the most sensitive instruments. only took the faintest trickle of sunlight to create contrast, almost too small to measure. Scientific uncertainty touches again when considering how many bodies inhabit this region. Estimates range from billions to trillions, depending on formation pathways and early dynamical histories. The narrator senses these vast populations not as individuals but as potentialities, orbits waiting to be discovered. Only took the uncertainty of initial conditions to produce a population size wide enough to span orders of magnitude. As this region continues outward, the motions of bodies grow increasingly shaped by external influences. Some objects begin to experience small but cumulative changes in their perihelion distances, gradually lifting them farther from the planetary region. Others find their orbits perturbed in subtle ways that will eventually place them into long-period comet trajectories. Only took the slow breath of galactic motion to alter the alignment of paths shaped billions of years ago. The narrator hovers at the outer edge of this transitional realm, sensing how the structure ahead shifts subtly toward the defining geometry of the true Oort cloud, a vast, nearly spherical distribution of icy bodies surrounding the solar system like a ghostly shell. Only took the combined influences of early stellar tides, giant planet scattering and galactic forces to build a region so large that its scale stretches halfway to neighbouring stars. The quiet truth settles across the vastness. The formation of the Oort cloud is not a single event but a long-layered process shaped by countless subtle interactions. And within that process lies one of the solar system's softest ironies. The objects farthest from the Sun are the ones that preserve its earliest history with the greatest fidelity. Only took distance to store memory. The space ahead grows colder, quieter, and more profoundly detached from the inner solar system's architecture, inviting the narration to drift onward into the first whispering boundaries of the Oort cloud itself. The narration drifts into the true beginning of the Oort cloud, a region where the solar system loses its familiar shape and stretches into near emptiness. Here the guiding sensation becomes the dissolution of every pattern encountered so far. No disk, no belt, no coherent clustering, just a faint sphere of ancient remnants moving through silence. The scientifically accepted fact grounding this moment is that the Oort cloud, though never directly observed, is supported by strong evidence from the orbits of long-period comets, whose trajectories trace back to a vast distant reservoir, spanning tens of thousands of astronomical units from the Sun. Only took the parabolic sweep of one returning comet to reveal a population too distant to see. The narrator glides through the inner reaches of this cloud, where the density of objects is extraordinarily low, perhaps a few icy bodies scattered across a region so large that even calling it sparse feels like an exaggeration. Each body drifts alone, separated from its nearest neighbour by distances greater than those between planets in the inner solar system. A poetic detail emerges in the stillness of these bodies. They do not tumble quickly or spin with marked rhythm. Instead, their rotations are slow, damped by billions of years of isolation, as if the cold vacuum has smoothed their motions into the quietest form of balance. Only took the attrition of time to calm motions that began in chaos. Yet a scientific uncertainty lingers gently in the background. The exact population of the Oort cloud remains unknown. Some estimates propose trillions of objects. Others suggest far fewer, depending on assumptions about the early scattering efficiency of the giant planets. Only took the difference of a few percentage points in dynamical modelling to stretch estimates across orders of magnitude. The narrator drifts near one icy remnant, a pale worldlet whose surface carries complex organic materials, irradiated by cosmic rays for billions of years. These tholin-rich coatings, reddish and dark, hint at chemical pathways preserved at near absolute zero. Only took sunlight faint as a distant memory to create a surface unlike anything found in the warmth of the inner solar system. The orbits here are enormous, some taking millions of years to complete a single loop around the Sun. These bodies travel slowly at aphelion, barely falling toward the solar system, before the Sun's faint gravity begins pulling them inward again. Their perihelia can lie anywhere from a few hundred to several thousand astronomical units. Only took a slight tilt in an orbit's orientation to determine whether a worldlet will ever revisit the planetary region. Stillness defines this region more than motion. Even gravitational influence feels soft, as if diluted by sheer distance. The Sun remains the central anchor, but its pull weakens to the point where a passing star, even one a light year away, can disrupt or reshape the paths of Oort cloud objects. The scientifically accepted fact is that stellar encounters over billions of years continually replenish and redistribute the cloud. Only took the slow drift of a neighbour star to send a comet inward, or lift another body outward beyond return. A poetic detail arises in imagining these bodies illuminated not just by the sun, but also by distant starlight. Every star in the sky contributes a fraction of a fraction of a fraction of brightness here, a diffuse glow that would be imperceptible to human eyes but measurable by sensitive instruments. Only took the cumulative shimmer of an entire galaxy to give the faintest suggestion of light to a world frozen in solitude. Yet another scientific uncertainty appears softly. The shape of the inner Oort cloud may be far from spherical. Some models propose a toroidal or flattened structure resulting from early interactions in the Sun's birth cluster, with the full spherical cloud forming only later as galactic tides gradually isotropize the orbits. Only took a slight difference in early stellar density to shape a reservoir that changed slowly across hundreds of millions of years. The narrator crosses into a region where the orbital inclinations of these objects appear nearly random. Some loop above the solar system's plane, others dip below in steep arcs. Many follow paths with no constraint to any particular orientation. Only took the smoothing influence of billions of years to erase the memory of the solar system's original disk. A poetic detail takes shape in the notion that these icy worlds move through space, as if unconcerned with the planets, their motion defined not by the architecture of the solar system, but by the vast geometry of the galaxy. Only took the quiet turning of the Milky Way to guide their distant arcs. The narrator senses the boundary where loosely bound objects begin to feel the galaxy more strongly than the Sun. This is the transitional threshold where a body's orbit may become unbound if perturbed slightly a region where the solar system slowly blends into the interstellar medium without a clear dividing line. Only took the faint pull of the galactic disk to challenge the Sun's gravitational hold. Scientific uncertainty returns gently when considering how deeply this region was influenced by early encounters in the Sun's birth cluster. Did the young solar system pass near massive stars? Did supernovae injections alter orbits? Did close stellar passages trap interstellar objects into early versions of the cloud? Only took the loss of evidence through time to render these questions unanswerable by direct means. Drifting deeper, the narrator observes how some objects in the inner Oort cloud may never become comets. Their perihelia are too distant for solar heat to trigger sublimation. They remain cold, inert, and unchanging for billions of years. These bodies are comets that never wake archives sealed forever. Only took the luck of a distant orbit to preserve these worlds indefinitely in their original chemical states. The scale of this region becomes increasingly surreal. Distances stretch into weeks of light travel time. Orbits become concepts more than curves. Time dilates into epochs. Only took a small outward shift from the scattered disk to enter a realm where astronomical units lose meaning. A poetic detail emerges in how the Sun itself appears here, not as the warm disk familiar to Earth, but as a bright star with no halo, no atmospheric glow, nothing but raw light travelling across interstellar darkness. Only took distance to transform the Sun from a star of life into a point of light among millions. The narrator senses how the inner Oort cloud gradually transitions into the outer Oort cloud, a region where the gravitational bond to the Sun becomes so weak that a passing molecular cloud, a distant star, or the slow drift of spiral arms can loosen orbits further. Only took the turbulence of the galaxy to shape the solar system's outermost shell. As Section 12 nears its quiet conclusion, the impression of this place settles without urgency. It is the most silent part of the solar system, shaped by everything that has ever passed near the Sun and everything the Sun has ever passed near. A sphere of icy memory, fragile, untouched, and enduring. Only took the entire history of the solar system to build a region so distant that even its existence is inferred from the faintest arrivals of long-period comets. And from here, the narration prepares to drift still farther toward the edge, where the solar system's influence ends and interstellar space begins, where the boundary between what belongs to the Sun and what belongs to the galaxy grows impossibly subtle. The narration drifts onward, crossing a threshold so subtle that it offers no visual marker, no sudden shift in light or texture, only a gradual loosening of the Sun's hold. Here the guiding sensation becomes the sense of leaving something behind without fully stepping away, gliding into the outer Oort cloud where distance eclipses every familiar scale. The scientifically accepted fact grounding this moment is that the outer Oort cloud likely stretches from tens of thousands to perhaps 100,000 astronomical units, forming a vast, nearly spherical shell of icy bodies bound only weakly to the Sun, easily perturbed by passing stars, molecular clouds, and the Milky Way's tidal field. Only took the faintest gravitational tether to hold entire swarms of ancient objects on paths longer than civilizations. The narrator drifts through the first wisps of this remote sphere, sensing how the density of objects becomes so low that the space feels almost empty. If a single object occupies a volume the size of Earth's orbit, the surrounding expanse remains silent. Bodies here are not arranged in belts or clusters. They move independently like solitary seeds suspended in a cosmic breeze. A poetic detail arises in the way each object carries its own orbit like a personal history. No interactions, no collisions, no reshaping of paths since the earliest epochs. Only took the absence of disturbances to let these bodies remain as untouched relics of the primordial disk. Yet a scientific uncertainty weaves softly through this region. The outer Oort cloud has never been directly observed. Its existence is inferred almost entirely from the trajectories of long-period comets whose inbound paths suggest distant origins. Estimates of the cloud's mass vary widely from a few Earth masses to only a small fraction of one. Only took the faint arc of a single comet to hint at a population billions of times larger. The narrator nears one of these distant bodies, an object perhaps tens of kilometers across its surface, coated in ices darkened by cosmic ray bombardment over eons. Its rotation is barely measurable. Its orbit may take millions of years. Its composition holds the unaltered chemistry of the early solar system. A poetic detail emerges in the way cosmic rays carve microscopic features into its surface, etching patterns that accumulate for billions of years. Only took the constant whisper of high-energy particles to sculpt landscapes smaller than grains of sand. Around this object, the Sun shines with the intensity of a bright star. There is no warmth, no brightness, no solar wind to speak of. Photons take days to reach this region. Signals take months to travel back toward the inner planets. Only took the enormous stretch of space to delay even the speed of light into perceptible slowness. The narrator drifts farther, following the faint gravitational contours of the region. Here orbits no longer form neat ellipses. Instead, they are broad, shallow loops distorted by external forces. Passing stars nudge perihelia. Giant molecular clouds perturb inclinations. The Milky Way's tide lifts and lowers entire swarms of distant bodies. The scientifically accepted fact is that these distant objects are constantly redistributed by galactic influences. Only took the rotation of the solar system around the galactic centre to stir this outer reservoir like a slow, celestial tide. Yet even as these forces act, the region remains quiet and unchanged in its overall structure. The outer Oort cloud endures because it is both fragile and resilient fragile. In its individual orbits, resilient in its totality. A poetic detail arises in imagining the cloud as a dandelion-like sphere, one where each seed drifts independently, yet the overall form persists across unimaginable timescales. only took the balance of gravity and distance to create a structure that is neither disk nor cluster, but a sphere of drifting remnants. The narrator glides past another distant worldlet, this one larger, perhaps 100 kilometers across, though estimates remain speculative. It spins slowly at surface coated with nitrogen ice mixed with carbon-rich compounds. But here even such icy materials remain inert. Sublimation is nearly impossible. Temperatures hover just a few degrees above absolute zero. Only took the absence of solar heat to freeze volatile compounds indefinitely. Scientific uncertainty deepens as the narrator considers the origins of these bodies. Some may have formed near the giant planets before being scattered outward by gravitational encounters. Others may have originated in the farthest reaches of the protoplanetary disk. A few might even be captured interstellar planetesimals trapped by the sun's gravity during early cluster interactions. Only took the messy dynamics of the solar system's youth to populate this region, with objects whose stories diverge before planets even existed. The narrator senses how the sphere itself shifts subtly over time. As the solar system orbits the galaxy, the outer Oort cloud is compressed and stretched by the galaxy's gravitational field. When the sun moves above or below the galactic plane, the tidal influence changes sign, altering the distribution of distant orbits over eons. Only took the solar system's gentle bobbing through the Milky Way to sculpt the slow breathing of this outermost shell. A poetic detail emerges in the idea that the Oort cloud, though tied to the sun, is shaped more by the galaxy than by the planets. The journey of the solar system around the galactic centre, one orbit every 200 million years, induces cycles of dynamical reshaping. Only took the galaxy's slow heartbeat to keep distant orbits shifting, in ways invisible to inner worlds. The narrator moves to a region where the gravitational hold of the sun approaches its limit. Here, escape becomes a possibility. A slight perturbation, a passing star, a drifting cloud, or even the cumulative effect of the galactic tide can unbind an object, entirely sending it drifting into interstellar space. Only took the smallest change in trajectory to erase the sun's claim on an icy traveller. Scientific uncertainty lingers here as well. How many bodies escape the Oort cloud each million years? How many comets does it send inward? How many are lost to interstellar drift? Only took the inaccessibility of observation to keep these numbers in the realm of educated inference. The narrator senses how the entire region stands as a record of early solar system scattering. Each object followed its own chain of interactions: a nudge from Jupiter, a push from Saturn, a passing star, a tidal shift, all culminating in a distant orbit that will last for millions or billions of years. Only took the combined outcome of ancient migrations to fill the sphere with worlds older than the planets themselves. As this region stretches outward, sunlight becomes so faint that even the notion of direction loses meaning. Up, down, inward, outward, these distinctions fade. The sun is merely the brightest point among countless others. A poetic detail emerges in imagining these distant worlds, navigating by starlight alone, the sun offering no more guidance than a beacon glimpsed across a frozen plain. Only took distance to turn the centre of the solar system into one star among many. The narrator drifts toward the boundary where the Oort cloud tapers into interstellar space. Here the gravitational fields of nearby stars begin to overlap. The sun's sphere of influence grows diffuse. Some objects hover near this edge for millions of years before deciding through the cumulative effect of perturbations whether to remain or depart. Only took the slow arithmetic of countless microforces to determine the fate of each distant body. As Section 13 settles, the impression is not of an ending, but of a gentle thinning. The Oort cloud does not stop. It simply fades into the galaxy, merging with the background of interstellar space. Only took the gradual loss of gravitational dominance to blur the line between solar system and the cosmos beyond. And now, with the quietest part of the solar system behind the narration, prepares to drift into the realm where belonging itself dissolves the heliosphere's distant boundary, the soft frontier where the sun's wind meets the winds of other stars. The narration drifts deeper into the quiet frontier where the solar system's presence becomes a matter not of certainty, but of diminishing influence. Here the guiding sensation becomes the soft awareness of boundaries that are not walls, but transition zones where the forces that define the sun's domain gradually give way to those belonging to the galaxy itself. The scientifically accepted fact grounding this region is that the heliosphere, the bubble carved by the solar wind, extends far beyond the planets enveloping the solar system in a protective sheath of charged particles before yielding to the interstellar medium. Only took the persistent breath of the sun to sustain a bubble reaching more than 100 astronomical units into space. The narrator approaches the heliopause, the delicate interface where the sun's outward flowing plasma meets the incoming stream of particles from the galaxy. This boundary is not smooth. It undulates in response to solar cycles, local interstellar variations, and magnetic interactions. A poetic detail emerges in the way charged particles swirl in slow drifting vortices along the boundary, forming shapes that resemble the soft-edge patterns of wind meeting water. Only took the meeting of two invisible winds to create structures no eye could ever see directly. Yet a scientific uncertainty lingers. The exact shape of the heliosphere remains debated. Classical models portray it as comet-like with a long trailing tail. Newer data from Voyager spacecraft and energetic neutral atom imaging suggest a more rounded or croissant-like shape. Only took a few surprising measurements at the edge of the solar system to overturn decades of assumptions about its global form. As the narrator moves through the inner heliosheath, the region between the termination shock and the heliopause, the solar wind slows, dramatically compressed and heated as it interacts with the interstellar medium. Particles here drift in turbulent flows carrying memories of solar flares, coronal mass ejections and cycles of magnetic polarity. Only took 80 or 90 astronomical units of travel for the supersonic solar wind to lose its speed and collapse into subsonic quiet. A poetic detail unfolds in the fading strength of the sun's influence. Magnetic fields twist into elongated loops, charged particles follow gentle spirals, and the steady pressure of the solar wind becomes a whisper. Only took the gradual diminishing of solar influence to make motion feel like drift rather than flow. The narrator continues outward, sensing how the interstellar medium grows gradually stronger. Hydrogen and helium atoms drift inward from the galaxy, interacting with the solar wind to form regions of charge exchange. These interactions create energetic neutral atoms that travel inward, revealing the structure of the boundary through their distribution. Only took the transformation of charged particles into neutral messengers to allow distant observatories to map the edge of the sun's domain. Yet scientific uncertainties persist. The density, temperature, and magnetic orientation of the local interstellar cloud remain subjects of active study. Measurements from Voyager suggest one set of values. Theoretical models propose others. Only took the passage of two aging spacecraft to show that the interstellar medium is more complex than previously expected. The narrator drifts closer to the heliopause itself, a region where the outward pressure of the solar wind and the inward pressure of interstellar particles reach equilibrium. This is the true frontier of the sun's plasma influence, not the boundary of its gravitational reach, but the limit of its energetic presence. A poetic detail emerges in the way magnetic fields bend and reconnect along this interface, creating a dynamic, ever-changing boundary that resembles the shifting outline of a cloud seen against twilight. Only took the interplay of two magnetic worlds to shape a frontier that never stands still. Passing through the heliopause, the narrator enters interstellar space. Here the plasma environment becomes dominated by the galaxy's interstellar medium, composed of sparse ions, atoms, dust grains, and cosmic rays. The particles move differently. Their temperatures differ. Their magnetic orientations contrast with those inside the heliosphere. Only took crossing the boundary of a bubble to enter a region where the sun's breath no longer shapes the flow of space. A poetic detail appears in the rarefied stillness of the interstellar medium. Although not empty, this region contains only a few atoms per cubic centimetre material, so thinly spread that a cubic metre of space might hold no more mass than a faint breath. Only took the incomprehensible scale of the galaxy to turn scarcity into normalcy. Scientific uncertainty deepens in this region as well. The local interstellar cloud, the patch of space the Sun currently travels through, has uncertain boundaries. Its density, temperature and magnetic structure vary unpredictably. Some models suggest the Sun may soon exit this cloud and enter a new interstellar region, altering the shape and pressure of the heliosphere. Only took the slow motion of the solar system through the galaxy to guarantee a constantly changing cosmic weather. The narrator drifts farther outward, sensing how the Sun's light grows ever fainter, though still bright enough to cast subtle illumination on dust grains scattered through the interstellar medium. These grains, enriched by supernovae and the winds of massive stars, drift into the solar system and settle onto planetary surfaces, including Earth. Only took the quiet rain of interstellar dust to enrich worlds with materials from stars long extinct. Beyond the heliopause, galactic cosmic rays become more numerous, no longer deflected by the strength of the solar wind. These high-energy particles, accelerated by distant supernova remnants, permeate space with quiet intensity. The scientifically accepted fact is that the heliosphere provides partial shielding against cosmic rays, and once outside their flux increases dramatically. Only took stepping beyond the Sun's magnetic protection to reveal the unfiltered cosmic environment. A poetic detail arises in imagining cosmic rays crossing unimaginable distances, travelling from dying stars to drift aimlessly through the galaxy. Each particle carries within it the memory of an explosion light years away. Only took the death of a massive star to send a charged messenger across millions of years of emptiness. As the narrator moves deeper into interstellar space, the boundary between belonging to the Sun and belonging to the galaxy becomes unrecognisable. The distances are so great, the density so low, and the influence is so subtle that identity dissolves. Is this still part of the solar system, or merely a region where the Sun's light is visible? Only took a shift in perspective to reveal how arbitrary boundaries become at such scales. Yet within this dissolution, a gentle irony persists. Even here, the Sun exerts gravitational influence, extending nearly halfway to the nearest star Alpha Centauri. Bodies in the far Oort cloud still orbit within this domain, though loosely. Only took the quiet persistence of gravity to maintain connection across trillions of kilometres. Drifting farther, the narrator senses how the solar system's structure has been shaped by every transition passed through, from the rocky planets inward to the asteroid belt's missing world, to the migrations of giants, to the icy belts beyond Neptune, to the scattering that seeded the Oort cloud. And now at this boundary, the forces at work are no longer those of planets, but those of stars, clouds, and the galaxy itself. Only took the widening of scale to reveal the architecture guiding everything from comets to stars. As Section 14 settles, the space around becomes quieter, still, preparing for the final outward drift, a movement into a region where the solar system ends not with a boundary, but with a gradual merging into the interstellar night. Only took the slow fading of the Sun's presence to lead toward the last realm of this long journey. The narration moves farther outward, still drifting into a region where even the idea of a boundary becomes too sharp, too defined for what the space actually is. Here, the guiding sensation becomes the dissolution of structure into vastness, the slow unspooling of the solar system into the wider galaxy. The scientifically accepted fact grounding this moment is that the Sun's gravitational influence extends to roughly 1 to 2 light-years, forming what is known as the Sun's Hill sphere, beyond which the gravitational pull of neighbouring stars overwhelms it. Only took the broad, slow curvature of the galaxy's gravitational field to set the true scale of the Sun's reach. The narrator glides through this outermost region, where the faintest remnants of the Oort cloud taper into the natural background of interstellar objects. These worldlets no longer form a coherent population. They fade one by one into the distances between stars, The space feels neither solar nor interstellar, only transitional, as though this region belongs to both realms and neither. A poetic detail emerges in the way the sun's light appears here, not merely a bright point, but one star among millions bearing no markings to distinguish it from its neighbours. Only took distance to turn a star of warmth and origin into one more spark in the galactic night. The narrator senses how the last gravitational threads of the solar system stretch thin. Objects in these regions move so slowly that a single orbit might require tens of millions of years. Some feel the sun's gravity only faintly held loosely, like a memory that has not quite faded. Only took the diluting of gravitational pull to let trajectories drift just enough that the difference between bound and unbound becomes difficult to define. Yet scientific uncertainty rests softly across this region. No spacecraft has ever reached this far. No comet has been definitively traced to such distances, and no direct observations confirm the structure of the outermost Oort cloud. Models provide guidance, but the true distribution remains unknown. Only took the sheer scale of the solar system to hide its outermost architecture from direct observation. As the narrator drifts deeper, encounters with free-floating interstellar objects become conceivable. The scientifically accepted fact is that the galaxy contains countless rogue planetesimals, bodies ejected from other star systems or formed independently in dense molecular clouds. A few have passed through the solar system, such as Oumuamua and Comet Borisov, revealing that interstellar visitors flow quietly between stars. Only took the early chaos of planetary formation to fill the galaxy with wanderers drifting between suns. A poetic detail emerges in imagining these interstellar objects moving through the sun's domain, without ever noticing it passing through the distant Oort cloud, as silently as dust drifting through a room. Only took the indifference of cosmic scale to let entire worlds slip through unnoticed. The narrator drifts alongside one hypothetical body, perhaps a fragment of icy rock from a star that no longer exists, or a shard from a disk long dispersed. Its path is straight relative to the sun, its velocity too high to be captured. Its chemical makeup holds the story of a stellar nursery light years away, preserved in frozen molecules. Only took the collapse of a distant molecular cloud to set this traveller wandering until it crossed paths with the solar system. Scientific uncertainty lingers. How often do such objects arrive? How many pass undetected? How many are trapped temporarily or join the distant reservoirs without ever revealing themselves? Only took the limits of technology to render these questions open-ended. As the narrator moves onward, the density of dust grows slightly, not enough to obscure vision, but enough to hint at the interstellar medium's complexities. Gas clouds drift faint and sparse at these scales, shaped by magnetic fields, turbulence and shock waves from ancient supernovae. Only took a distant stellar explosion to scatter dust that now travels freely across light years. A poetic detail arises in the way dust grains align with magnetic fields, their orientations controlled not by gravity, but by forces far more delicate. Their alignment polarizes starlight passing through them, creating subtle signatures that astronomers detect from Earth. Only took the quiet spin of dust to encode information about fields spanning parsecs. The narrator senses how the sun itself moves through this medium, not fixed, not stationary, but drifting along its orbit around the Milky Way at roughly 200 kilometers per second. The interstellar gas flows around the heliosphere like wind around a ship, shaping its boundary, eroding it, sculpting patterns in the plasma. Only took the steady movement of one star among several 100 billion to turn the heliosphere into a structure moulded by galactic weather. The region ahead grows even quieter. The sun's influence now becomes a faint suggestion, overtaken by the gravity of the galaxy at large. Stars are no longer distant lights, but potential neighbours whose gravitational fields subtly overlap with the sun's. If a body drifts far enough, a nearby star's influence may exceed the sun's entirely. Only took the gradual accumulation of distance to loosen the last threads of the solar system's identity. scientific uncertainty reappears in questions about the future of these outermost bodies. Over billions of years as the Sun moves through the galaxy and encounters different stellar environments, the structure of the distant cloud will shift, perhaps thinning, perhaps replenished by new gravitational captures. Only took the slow passing of stars to rewrite the farthest edges of the solar system again and again. A poetic detail appears in imagining the future trajectory of the Sun itself. In 250 million years, it will have completed another orbit around the Milky Way. In 1 billion years, the distribution of distant bodies will be completely different. Over such timescales, the Oort cloud may be sculpted anew. Only took the slow churn of the galaxy to ensure no boundary remains permanent. As the narrator moves into the deepest part of this transitional region, interstellar space becomes dominant. The Sun's gravity lingers but does not define. Its light shines but does not warm. Its presence is a point of memory rather than a source of local structure. And in this vastness, an irony emerges: the most distant objects of the solar system belong to it, least yet preserve its earliest history the most faithfully. Only took distance to protect their ancient chemistry from every process that reshaped the planets. The narrator drifts farther still, sensing the outermost limit of the Sun's hill sphere. This conceptual boundary represents the final reach of the Sun's gravitational dominance. Outside it, objects feel neighbouring stars more strongly. Inside it, objects may still orbit, though loosely. Only took the balancing of forces to define a region where belonging becomes ambiguous. A poetic detail arises in viewing the sky from this boundary. The Sun and Alpha Centauri appear nearly equal in brightness. The line between which star claims the region is indistinct, governed by slow shifts in distance and mass. Only took proximity to another stellar system to make the solar system's edge a shared frontier. Even here, the possibility of capturing new objects remains. Interstellar debris passing close enough could enter bound orbits, becoming part of the Sun's distant reservoirs. Likewise, objects at the very edge could escape, drifting open-ended into the galaxy. Only took a small gravitational nudge to exchange membership between stars. The narration finally pauses, suspended between two domains, not fully within the solar system, not yet beyond it. The outer frontier is neither a shell nor a barrier, but a gradient, a place where identity dissolves into the shared gravity of the Milky Way. Only took the widening of perspective to reveal how every boundary in space is softer than it seems. And now the movement slows, preparing to enter the final wind down, a settling into stillness where motion, history and structure all dissolve into the quiet of cosmic night. The narration loosens now, unspooling from the long arc of its journey, until movement itself becomes optional, until direction fades, and only the quiet remains. Out here, far beyond the Sun's bright architecture and the pathways of planets, the sense of distance softens into something indistinct. There is no boundary to cross, no threshold to mark a transition, only a gradual settling into the calm that surrounds everything at this scale. The scientifically accepted fact that even out here, the Sun continues to exert a faint gravitational pull becomes less an idea and more a gentle reminder that influence persists, even when its strength feels almost absent. Only took the thinning of light to make the Sun seem like a star among many familiar yet no longer central. No. A poetic detail drifts through the darkness, dust grains moving slowly in the glow of distant starlight, each one turning with a quiet glimmer too small to shape anything large, but enough to leave a trace of presence in an otherwise silent expanse. Only took the faintest shine to give form to the smallest particles. A soft uncertainty lingers, though it no longer presses for answers. How many worlds remain unseen? How many comets drift in solitude? How many stories lie embedded in fragments that will never return to the Sun? Only took distance to turn every unanswered question into a gentle open space. The narration slows further. Time stretches easily here, unspooling into long, unhurried breaths. There is no pull to continue outward, no need to return inward. The The galaxy surrounds everything with patient quiet, and the solar system, once vast and intricate, becomes a single luminous thought drifting through wider dark. Motion fades, then memory, then the sense of scale itself. What remains is simple: the stillness of cosmic night, the softness of dust, the unhurried movement of stars across epochs too long to measure. The journey that traced the sun's domain from its warm interior to its faint outer frontier now settles into rest, not as an ending, but as a pause without urgency. Nothing requires resolution. Nothing presses forward. The vastness accepts everything without question. And so the narration eases into silence, letting the quiet deepen until it feels almost tangible. A gentle place to rest, without edges, without weight, without expectation.